Okay, so in this video I'm going to look at problem 2 from the first homework set. So this problem concerns the function f of t equals 5 plus 6 times 2t plus 1. So the first thing I'd like to do is sketch a graph of this function. Because we're asked to determine what the inverse of the function is if it has one. And so if we're going to do that, we should first see, is this function invertible or not? So if we plug in t equals 0, we see that this function has a value of 17. And then after that it behaves like a typical exponential function, so it has some exponential growth, sort of like this. And so this is just a rough sketch, but we can see that it does pass the horizontal line test, so the function is invertible, so we should be looking to find the inverse. And to do that, we're going to switch the domain and range variables, which in this equation amounts to switching the t with f of t, which we can think of as y. So if we write this as y equals 5 plus 6 times 2t plus 1, and then we interchange y and t, then what we'll get is t equals 5 plus 6 times 2 to the y plus 1. And now we want to try to solve for y. So the first thing we want to do is move that 5 to the other side. So at t minus 5 equals, and let's divide by 6 while we're at it, 2 to the y plus 1. Now we somehow have to get this y out of the exponent. And the way to do that is using logarithms. Since the exponent, the base of the exponent here is a 2, I'm going to take log base 2 of both sides. And then we can simplify this using properties of logs. We can pull the y plus 1 out front. And we have log base 2 of 2. But log base 2 of 2 is just equal to 1. And so therefore, if we solve for y by subtracting 1 to the other side, we get y equals 1 minus log base 2 of t minus 5 divided by 6. Okay. And so now, if we want to plot this function, the way we plot the inverse function is we draw the line y equals x, and reflect across this line. So if this is the point 5, we'll end up getting something which looks roughly like this. So this function up here is f of t, and this function down here is f to the minus 1 of t. And this is our equation for the inverse function.